So today I will be discussing about a MOS fabrication method. And MOS fabrication method, before going into the detail, we just know about the stick diagram and our layout design rule for our layout. So if you know the layout process, then we can easily fabricate a CMOS inside a single wafer or any MOS circuit inside a wafer or this wafer or substrate. CMOS fabrication process basically consists of three type of method. Here one type method is called our N-tub method, another method is called P-tub method, and last method is called twin tub method. So we'll discuss first the N-well method or N-tub method. So first step is that we have to take the base material. That base material may be called your blank wafer, and for our N-well formation we choose the P-type material for your base or substrate. So this first step is that to form our N-well, cover the wafer with a protective layer of SiO2 and remove the excited layer where N-well should be built. This is shown in the figure. So first one is that we have to give the oxidation process on that wafer or P substrate, and this oxidation process is taking place at the temperature of 900 to 1200 centigrade with water or oxygen in oxidation furnace. So we are getting a SiO2 layer on that P substrate. This is shown in the figure. Next one is deposition of our photoresist layer. So spin on photoresist. Photoresist is basically a light sensitive organic polymer. So there are two type of photoresist. One is called positive, another is called negative. Positive resist means it can be removed if exposed to UV light. Negative photoresist means that cannot be removed if exposed to UV light. So for next step is to spin on a photoresist. We put a photoresist layer on SiO2 layer for a pattern transformation. So this is shown in that figure. Next you have the photolithography technique. We just expose our photoresist layer to UV light through the N-well mask. This is shown in the figure to make a window for our N-tub process. Then strip of exposed photoresist with some chemical. Then etching is basically done with a hydrofluoric acid. So only attack oxide where the resist can be exposed. So N-well pattern is transformed from the mask to silicon dioxide surface and create an opening to the silicon surface. This is clear from this picture. Then strip off the remaining photoresist, use a mixture of acid. Then the next process is the N-well or N-tub formation with a diffusion process, or it may be ion implantation process. For a diffusion process, the wafer will be placed inside a furnace with the arsenic rich gas and heat until arsenic atom diffuse into our exposed silicon. In case of your ion implantation method, there will be a ion bombardment of our arsenic ions, and ions blocked by SiO2 only enter into that exposed Si, so that only window will allow that Si atom form atom or ions for that bombardment process. Then SiO2 cells or mask areas with the remaining p-type material. That means the upper portion of this SiO2 will protect that entire p substrate. Only the NOL or n-type portion will be diffused through some arsenic ion. Maybe it may be by using a diffusion process, or it may be your ion implantation process. Then the unwanted SiO2 layer are removed or stripped off by using hydrofluoric acid. Only n-tub is formed on a p substrate. This is shown in the figure. So next step is to form our gate material. Here the gate material is nothing but a polysilicon. Here this polysilicon is deposited on our substrate by using a process that is called chemical vapor deposition on a silicon surface. So here first our wafer is placed in a furnace with a sullen gas SiH4, and that forms basically a small crystal that is called a polysilicon, and heavily doped polysilicon will be a good conductor. So here polysilicon material is used for our gate material. So within a thin oxide layer we have a polysilicon layer. This is shown in the figure. And thin oxide layer basically less than 20 Armstrong, and the polysilicon is basically deposited on that thin oxide layer, and the thin oxide layer basically less than, the thickness of this layer is less than 20 Armstrong. This is also shown in the figure. Then our polysilicon pattern transformation is very important, and that's why similar earlier process we can transfer that pattern for that polysilicon for our gate material. And since we are trying to implement our CMOS on a single wafer, so we have a two gate, one gate for our PMOS, another gate for our NMOS. So the polysilicon material used for this two gate for this two MOS. Then again the SiO2 layer or oxidation layer is formed to protect our base material or polysilicon, and next step is to make a window for the pattern transformation for N diffusion region. So N pattern side and forms N plus region. So the pattern transformation is shown in the figure. With this pattern transformation within this window we can use a ion implantation method. So N plus regions are formed for source and drain. This is shown in the figure. Then after pattern transformation we just strip off our oxide layer when we get our full pattern transformed on that P substrate as well as on our N tab. This is shown in the figure. So 2 N plus region is formed on a P substrate and 1 N plus region is formed on our N tab. Then P diffusion is performed after pattern transformation. So here P plus region is formed, and also for a P substrate, and P2P plus region is formed for our N tab. This is shown in the figure. So the complete circuit we get for P plus region for P substrate represent our P substrate terminal. Here N plus region for N tab represent our substrate for our PMOS. So next step is to make our contact. So the contact pattern is transformed. Again the same process has been utilized. So first we make a oxidation process, field oxide FO, then pattern is transformed where it needs, and the oxide will be etched by using acid. So the metal contact is formed, and the metallization basically used by the method called as sputtering method, by using this sputtering method we can make that metal contact for source, drain, and get here P plus region for our P substrate represent our substrate. Here this region represent your N channel MOS. In that N tab we have a P channel MOS where N plus region represent for that substrate. So this is all about the formation of our CMOS by N-tub method. By using this N-tub method we can get a CMOS fabrication where on a single wafer we can implement both PMOS and NMOS. Thank you.